Welcome to Conceptual Cambridge. Today we are going to go over part 2 of the series video. So let's begin with arithmetic progression. You can see that any series or any progression that has a difference which is constant. So for example, as you can see, I've taken 1, 3, 5, 7, 9. There is a constant difference between the values and that constant difference is 2. So basically this is any progression or any pattern which has a common difference, and it should only be addition or subtraction. It cannot be multiplication or division. So now on the right hand side, as you can see, I've taken two formulas from your formula sheet. So what we are going to do is discuss them. Now first, to understand those formula, we have to discuss the variables involved. So as you can see, the variables are a, d and n. So what is a? A is supposed to be your first term. So in the case, as you can see, 1, 3, 5, 7, 9, my first term is supposed to be wherever my series starts from. So in this case it is 1. Now what is d? D is supposed to be the difference in between the value, the common difference, which is 2 in this case. Now what is n? N is the location of the value. So for example, as you can see, what value is 5? 5 is n is equal to 3. Now 7 is n is equal to 4, and so on. So this is the location value. So now let's see why do we use these formulas and where do they come from. To understand that, let's see if 1 is a, what is 3? 3 is basically a plus the difference. And then what is 5? 5 is a plus 2 times the difference. What is 7? 7 is a plus 3 times the difference. And what is 9? A plus 4 times the difference. Now if you see, we can go back to our formula and you can see what I've done. So I've taken their locations and subtracted 1 from them and then multiplied it by the common difference. And now let's say I was supposed to find 5 and I only have its location, which is 3. So now using its location, I'm going to find 5. So let's see, 1, the location is 3, so 3 minus 1, and then the common difference is 2. So 1 plus 3 minus 1, which is 2, into 2, this gives me 5. This is how you are supposed to find the value if you are given the location, or vice versa. Now let's discuss the sum. So for the sum, basically this is the original formula, and then we just make the L into another form and find and expand the formula. So basically, what is the sum of 1 plus 3 plus 5 plus 7 plus 9? It is going to take a lot of time if we are going to do this. This is why we are supposed to use the formula. But just in case, let's see. This is 25 if you use your calculator. And now let's use our formula, 1 over 2n, which is basically n over 2 into 2a plus n minus 1 into d. Now n is also the number of values, which is 1, 2, 3, 4, 5. So 5 values, 5 over 2 into 2 times 1, which is 2, plus n minus 1, which is 4, into 2. If you look at it, you will get 5 plus 5 over 2 into 8. 5 over 2 into 8. This gives you 25. We are going to derive this formula in another video. Now let's move on to another type of question for arithmetic progression. So here I've taken a question from the past papers. So let's try and solve it. Over a 21-day period, an athlete prepares for a marathon by increasing the distance she runs each day by 1.2 km. On the first day, she runs 13 km. Find the distance she runs on the last day of the 21 period. So for this, let's see. On the first day, she runs 13 km. On the second day, it's going to increase by 1.2, so 14.2, and it goes on, so 15.4, 16.6. So first day, second, third, fourth, and so on. So for the 21st day, we can just apply the formula. So we have our A is equal to 13, our D is equal to 1.2, and the N we need is the 21st. Alright, so 13 plus 21 minus 1 gives me 20 into 1.2. So this gives me 37 kilometer. So this is my first answer. And now we need to find the total distance she will run in the 21st day period, 21 day period. So let me just erase this. Now let's apply the formula. So 21 over 2 into 2 times A, which is 2 times 13, plus n minus 1, so 21 minus 1, 20 into 1.2. So this is going to be our answer, and our answer comes out to 525. Now let's move on to geometric progression. So here we have geometric progression. So this is any series or any pattern with a common ratio in which you can multiply or divide by a specific number. So now let's see, is there any pattern in the numbers provided 2, 6, 18, 54? As you can see, this is being multiplied by 3, then this is being multiplied by 3, then this is being multiplied by 3. So they all have a certain pattern. If you look at this, you can also see that if you wanted to go from 2 to 18, what you can do is multiply it like this into 3 square, or if you wanted to go to 54, 2 into 3 cubed. So this is where the formula ar to the power of n minus 1 comes from. R is basically supposed to be the common ratio. So now let's discuss the sum. As you can see, we have two formulas for sum. For this, there is also an infinite sum formula which only applies when r is less than 1. Hence, we cannot use that formula over here. So for now, let's use the second formula and see what is going to be the sum of all of these numbers. So this formula only applies when r is less than 1. If your r is greater than 1, for example, here we have 3, which is our r, so the formula changes into something like this, over r minus 1. So this is going to be our formula when r is greater than 1. Alright, now let's try and apply it. So our answer is going to be 2 into 3 raised to the power of 4 minus 1, over 3 minus 1, which is 2. Our answer comes out to be 80. You can also verify this by manually adding the values. Now let's move on to an example question from the past papers. So let's see, our question states that the first, second and third terms of a geometric progression are x, x minus 3 and x minus 5 respectively. So we have to find the value of x. So if you see a geometric progression first of all, then you would know that the first term is a, then it's going to be a multiplied by the common ratio, then ar squared and ar cubed as we discussed earlier. So let's say we want to find the common ratio. So for finding the common ratio, what you're going to do is see the third term or the fourth term, whichever is in front, take it in the numerator, ar square over ar. If you look at this, you can see that you can cut out this, this and this. It will give you r. So now let's try that. So here we are going to form a simultaneous equation for this, I think. So x minus 3 over x is equal to r, and the other is supposed to be x minus 5 over x minus 3 is equal to r. Yes, so now we can solve it. Let me put it over here, x minus 3 over x, and now we can keep it equal to one another. It's 5 over x minus 3. So now let's see, what I get is x minus 3 squared is equal to x square minus 5x. Right now, let's see if I open the brackets. X square minus 3x gives me minus 6x plus 9 is equal to x square minus 5x. I can cut the x square out from both sides. Then bring the 6 over to the right side, minus 6. So this gives me 9 is equal to minus 5 plus 6, which is equal to x. So I have my answer, 9 is equal to x. Now let's move on. Find the fourth term of the progression. As we discussed earlier, we had our answer for x, so our progression is going to be 9. 9 minus 3 gives me 6, and then 9 minus 5 gives me 4. So first of all, our value for r is what we are going to find. So let's see, 6 over 9 we can do this, or we can do 4 over 6, which is equivalent to 2 over 3. This is also equal to 2 over 3 if you divide both sides by 3. Alright, so we have our value for r. Now what we can do is use the formula that we already have for geometric series and apply that to find the fourth term. So let's see, our a is 9, then 9 into 2 over 3 raised to the power of 4 minus 1. So this is going to give us our fourth term. Now let's see what the answer is. Our answer comes out to be 8 over 3. Let it 8 over 3 or 2.67. So this is second part of the question. Now let's move on to the third part of the question, which says find the sum to infinity of the progression. So for sum to infinity, you can just apply the formula. Let's see, a over 1 minus r, so 9 over 1 minus 2 over 3. So this is going to be 27. So here we have our answer. So now we have finally reached the end of this video. So now we are going to solve topical questions from this topic. All right.